Okay, engine stop. APA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 13 is in.
We copy you down, Eagle.
Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
And we're getting a picture on the TV. There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail. Okay, Neil, we can see you coming down the ladder now.
Sunday, July 20th, 1969. Around the world, nearly 1 billion people watched this moment on television as the first man from Earth prepared to set foot upon the moon.
At the foot of the ladder, the LEM footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
All that we have accomplished in space, all that we may accomplish in days and years to come, we stand ready to share for the benefit of all mankind.
As we explore the reaches of space, let us go to the new worlds together, not as new worlds to be conquered, but as a new adventure to be shared.
Since the earliest time, man has imagined this moment, the moment when his fellow man would make the first journey to the moon. Now the time had come. In the 6th decade of the 20th century, the ancient dream was to become a reality. The flight of Apollo 11 was the culmination of many years of planning, working, building, and testing. Thousands of people had contributed toward this day of accomplishment. The great Saturn V rocket and the complex Apollo spacecraft had been assembled together and moved to the launch pad. The equipment and techniques and personnel had been proved in earlier missions, and now they were ready. The astronauts chosen for this mission had flown it many times in ground-based simulators. They had all been in space before. They had trained carefully and well, and now they too were ready. Astronaut Michael Collins would pilot the Apollo command module. Astronaut Edwin Aldrin Jr. would pilot the lunar module. And astronaut Neil Armstrong would serve as mission commander. Armstrong would be the first man to step upon the moon. July 16th, the day had come. The moon awaited. The men rose early, ate breakfast, and dressed in their spacesuits. Other astronauts had made this journey to the launch pad, but never with such anticipation. 9:32 a.m., July 16th. 3 hours later, the Apollo command module moves forward to extract the lunar module from the third stage of the launch vehicle. Both are moving at more than 17,000 miles an hour. Docked together, they will sail 250,000 miles across the sea of space and into orbit around the Earth's nearest neighbor.
Oh, loud and clear now, Mike, and we understand that you are docked.
During the 3-day journey to the moon, the astronauts kept busy. Checklists, navigation and observation, housekeeping. They must work in a weightless environment, keeping their spacecraft and themselves in good condition. Data must be collected and reported. Experiments must be performed, including photography both inside and outside the spacecraft. Because of the film speed, these actions appear faster than they actually were. July 19th. Apollo 11 slows down and goes into orbit around the moon. The bright blue planet of Earth now lies 238,000 miles beyond the lunar horizon. Astronauts Armstrong and Aldrin, now in the lunar module, separate from the command module. Astronaut Collins remains behind. Preparation for the lunar module descent to the moon now begins. The command module assumes the new name, Columbia. The lunar module will be called the Eagle. From Columbia, Michael Collins' camera sees bright rays of the sun reflecting patterns of color from the surface of the Eagle. In this strange metallic bird rides the ancient and endless dream of all mankind. The command pilot can see detail which his camera cannot record. The 4 landing pads of the lunar module are fully extended and locked in place. The Eagle is poised and prepared for its descent to the lunar surface. The moon landing craft rocket engine fires to slow it down and to place it on the pathway to the landing site in the Sea of Tranquility. There is tension and caution as the Eagle flies lower. Warning lights blink on as the computer tries to keep up with the demand for control data, but the status remains go.
Eagle, we got you now. It's looking good, over.
Roger, copy.
Eagle Houston, after yaw around angles, S-band pitch, -9er, yaw, +18. Roger, you're a go to continue power descent. You're a go to continue power descent.
Altitude now 21,000 feet, still looking very good. Velocity down now to 1,200 feet per second.
You're looking great to us, Eagle.
Give us a reading on the 1202 program alarm.
Roger, we got you. We're going at alarm.
Good radar data. We're now in the approach phase, everything looking good. Altitude 4,200.
Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet.
Copy.
Alarm.
Altitude 1,600. 1,400 feet, still looking very good.
700 feet, 21 down. 33 degrees. 100 feet, down at 19. 1201. 1201.
Roger, 1201 alarm. We're go. Same type. We're go.
Altitude, velocity, light. 8.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down.
60 seconds.
Lights on. 6. Down 2.5. Forward. Forward. Good. 40 feet, down 2.5. Picking up some dust. 4 forward. 4 forward. Drift into the right a little. Good. Okay. Contact light. Okay, engine stop.
We copy you down, Eagle.
Tranquility Base here. The Eagle has landed.
Through the window of the Eagle, Armstrong and Aldrin see what no human eyes have ever seen before. Their spacecraft casts a long shadow across the undisturbed dust of centuries. Seven hours after landing, after careful preparations for later ascent were completed, Armstrong opens the Eagle hatch and begins his climb down to the surface. The first footsteps on this strange new world must be taken cautiously. The moon has only 1/6 the gravity of Earth. The nature of its surface was still unknown.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Once on the surface, Armstrong scoops up a small sample of lunar dust and rock, precaution against the possibility of an emergency takeoff. According to plan, astronaut Aldrin now descends from the Eagle. He and his equipment would weigh 383 pounds on Earth. Here, they weigh about 66 pounds. For a brief moment, the first men on the moon stand and look at the stark, lonely landscape around them, an experience which no one before them can share. But there is much to be done in the limited time which they can stay on this airless, cloudless satellite of Earth. This sheet of metal foil traps and holds particles from the sun, the so-called solar wind, or barrage of solar energy, which constantly strikes the moon's surface. Results of this experiment will be taken back to Earth to reveal new secrets to anxious scientists. An American flag is left behind on the moon, together with medals honoring American and Soviet spacemen who lost their lives in earlier space tests, and a small disc carrying messages of goodwill from 73 nations on Earth. A plaque on the lunar module reads, Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind. Through a specially made television camera, viewers in many nations on Earth were able to watch the astronauts as they walked and worked on the moon. Despite the bulky spacesuits and the backpacks containing oxygen, temperature control, and communications equipment, the Apollo 11 crew found they could move easily about the surface. Because there is no wind or rain on the moon, these footprints will remain for centuries. In addition to collecting rock and soil samples, the explorers leave behind a seismometer. This highly sensitive device would send back valuable information on external meteoroid impacts, as well as internal lunar movements. A 100-prism laser reflector would help man to measure the exact distance from Earth to Moon to an accuracy of 6 inches. These were the first of many experiments which will be taken to the Moon to provide man continuing and increasing knowledge about the Moon and the vastness of space beyond. After 2 hours and 31 minutes, the first lunar explorers had completed their research on the Moon. A night of rest in the lunar module, countdown preparations, and they were ready to come home.
Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff.
Roger, understand. We're number 1 on the runway. 7, 6, 5, work stage, engine arm ascent. Beautiful. Very smooth. Very quiet ride. There's that one crater down there.
Feet high, 80 feet per second vertical rise. Eagle Houston, you're looking good at 2. Ping, zags, and misspin all agree.
I'm going right down US 1.
Eagle Houston, going right down the track. Everything's great. Horizontal velocity approaching 2,500 feet per second. Roger. Some 120 miles to go until insertion.
July 21st. The Eagle and its 2-man crew lifted off the Moon perfectly and climbed slowly to rendezvous and dock with the mother ship, Columbia. While Armstrong and Aldrin explored the Moon, astronaut Collins had kept a long and lonely vigil in the Columbia. The approaching Eagle was a welcome sight. Later, the 3 men would share their reflections on this adventure with the world.
I believe that from the early space flights, we demonstrated a potential to carry out this type of a mission. And again, it was a question of time until this would be accomplished.
I think it's a technical triumph for this country to have said what it was going to do a number of years ago, and then, by golly, do it.
The relative ease with which we were able to carry out our mission, which, of course, came after a very efficient and a logical sequence of flights, I think that this demonstrated that we were certainly on the right track when we took this commitment to go to the moon.
I just see it as a beginning of a new age.
Once again, the bright blue planet of Earth rises over the lunar horizon. For those who had witnessed man's landing in the Sea of Tranquility, the moon would never again appear quite the same. July 24th, dawn in the Pacific. Apollo blazes across the heavens, coming back to Earth at 25,000 miles an hour. President Richard Nixon, who had talked with the astronauts by telephone while they were on the moon, was waiting aboard the recovery carrier to welcome the returning voyagers. The president later expressed the nation's response to this historic mission.
Some way, when those two Americans stepped on the moon, the people of this world were brought closer together. That it is that spirit, the spirit of Apollo, that America can now help to bring to our relations with other nations. The spirit of Apollo transcends geographical barriers and political differences. It can bring the people of the world together in peace.
To protect against any possible lunar contamination, the astronauts put on airtight special garments before coming aboard the rescue ship. They transferred directly from the helicopter to a mobile quarantine van, in which they would be flown back to the Manned Spacecraft Center in Houston, Texas. July 27th. The journey was ended. They were home again. Ahead lay 3 weeks of isolation, medical tests, and mission debriefings. Then visits to major cities of America and abroad. The details of their unique mission would be relived and remembered so that others might learn what they had learned, and that future travelers in space might build upon their experience. The rock and soil samples brought back would be examined and analyzed by scientists in many lands. They would reveal new insights into the origin and the age and the composition of the moon, and perhaps new knowledge of the Earth as well. Already experiments left on the moon were sending back revealing new information. The mission was successfully completed. The Eagle had landed the first men on the moon, and Columbia had returned them safely to Earth. Wherever man journeys tomorrow across the ocean of our universe, history will remind him that Apollo 11 was mankind's first encounter with a new world.
Mission sequence start. 6, 5, 4, 3, 2, 1, 0. All engines running. Commit. Liftoff.
Apollo 12 lifted off in the driving rain.
Pete Conrad reports that your program is in. Tower clear.
The pitch and a roll program, and this baby is really going.
36 seconds later, lightning struck the spacecraft.
I don't know what happened here. We had everything in the world drop out. I'm not sure if you get hit by lightning. Fuel cell lights and AC bus light. Fuel cell disconnect. AC bus overload 1 and 2. Main bus A and B out. Okay, we're all organized again, John. We've had a couple of cardiac arrests down here too, Pete.
Now they settle down to the routine of the outward flight.
We're trying all these things that we didn't have in Gemini, like toothpaste and shaving, and we're really having a ball up here. Roger. All dressed up and no place to go. Oh, we're going someplace. We can see it getting bigger and bigger all the time.
Then, on November 17th, they prepared for orbit around the moon.
Our motion to the left is not as apparent as our motion towards the moon, and therefore we have the decided impression that we're going right into the center of that baby right now. Okay, Houston, we're maneuvering to the burn attitude. Rod, we copied that 12.
The next day, Pete Conrad and Alan Bean entered the lunar module, leaving Dick Gordon in the command module. Now the Intrepid and Yankee Clipper undocked and separated, preparatory to Intrepid's descent and landing on the moon.
Okay, here you go again. Maybe. Back off, Dick. There he goes. Hey, Houston, the sim's running pretty smooth today. Affirmative, Pete.
As with the orbit insertion burn, the burn to begin descent was made behind the moon. Mission Control again contacted Intrepid as it came over the horizon.
Intrepid, Houston, how do you read?
Hello, Houston Intrepid. Roger, we read you loud and clear. We had a great DOI burn. And we just watched the first Earthrise, which was fantastic.
But now it was time to exit the Intrepid and begin the exploration and experiments. Conrad climbed out first.
you what we're parked next to? What? We're about 25 feet in front of the surveyor crater. That's good. That's where we want it to be. I bet you when I get down to the bottom of the ladder, I can see the surveyor. Okay. Down to the pad. Okay. Man, that may have been a small one for Neil, but that's a long one for me. Oh, you'll never believe it. That's what I see sitting on the side of the crater. The old surveyor, huh? The old surveyor, yes, sir. Does that look neat? It can't be any further than 600 feet from here. Yes, we have the flag up. Like I say, I hope everybody down there is proud of it. If we are to put it up, that's affirmative, Pete, and we're proud of what you're doing.
They prepared an experiments package to be left on the moon, an automated scientific station called ALSEP that would send information to Earth for a year, powered by a nuclear electric generator.
Okay. And we'll offload the ALSEP, I guess. No. We ought to be able to move out with this thing.
They moved to the site selected to set up the station.
Hey, there's another one of those mounds over there. Where? Hey, you're right. What do you suppose they are? I don't know. It looks like a small volcano.
They put together the experiment station.
How far do you estimate we're from the lamp? 600 feet? 700 feet?
ALSEP, an acronym for Apollo Lunar Surface Experiments Package. Piece by piece, they assembled the station.
Okay. I got the solar wind deployed here.
The solar wind experiment, to measure atomic particles thrown off by the sun as they strike the moon. A device to measure the moon's tenuous atmosphere. A magnetometer to measure the lunar magnetic field, which would later be found to be 10 to 20 times stronger than many scientists had expected. A seismometer to measure physical properties of the crust and interior. And the data station to collect the experimental measurements and transmit them to Earth. With ALSEP deployed, Conrad and Bean began collecting geological samples.
Oh, God. Oh, there's a rock. Look at that. Son of a gun. I gotta have that.
They drove a core tube into the surface to collect soil from various depths.
Okay, I'm core tubing it right now. Kill. Auger it a bit and pound it. But now it's full length.
We show you're 3 hours and 7 minutes into it, into the EVA. And we'd like you back to the LEM to start the closeout in 10 minutes. That's at 3 + 17.
Bean re-entered the lunar module first. Conrad, using a transfer apparatus similar to a clothesline reel, sent the samples up to him. Then, Conrad, too, left the lunar surface.
Okay. Houston, if you can mark me off the lunar surface.
Roger, we got that, Pete, at 3 hours and 50 minutes into the EVA.
Yeah, up the ladder I come. I hope.
So they rose to their rendezvous, and from Dick Gordon and Yankee Clipper,
Please sure look straight down there amongst all the sand dunes. All right. At half a mile, 19 feet a second. Been looking better all the time, Yankee. Okay, I'm down to 3 feet a second.
Intrepid station keeping with the Yankee Clipper.
the two vehicles moved together for docking.
Okay. Steady as a rock. Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem. We've had a main B bus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
And we had a pretty large bang associated with the caution and warning there. And as I recall, main B was the one that had a amp spike on it once before. In the interim here, we're starting to go ahead and button up the tunnel again.
The sensation I had, that I had felt a vibration accompanying the bang, not a large vibration or shudder.
Is there any kind of leads we can give them? Are we looking at instrumentation, or we got a real problem, or what?
We're reading 0 N2 pressure in fuel cell 1 and 13 psi on fuel cell 3 O2 pressure.
Okay, Barrett, what do you want to do? Open circuit fuel cell 1 and 3?
That's firm flight.
Shut down the reactance valve, and I asked for reconfirmation, since when you do that, it's sort of irreversible. If you shut one of these things down, they only can be restarted from ground support equipment.
Yeah, that's because of AC. And it looks to me, looking out the hatch, that we are venting something. We are venting something out into space.
Okay, let's everybody think of the kind of things we'd be venting. GNC, you got anything that looks abnormal in your system?
Negative flight.
How about you, Ecom? You see anything that, with the instrumentation you got, that could be venting?
That's firm flight. Let me look at the system flight as far as the venting is concerned.
Okay, let's start scanning.
Here is a bulletin from ABC News. The Apollo 13 spacecraft has had a serious power supply malfunction that could cause the lunar landing mission to be terminated early.
My concern was increasing all the time. It went from, I wonder what this is going to do to the landing, to I wonder if we can get back home again.
Okay, Ecom, I'm coming back to you.
Flight.
Go ahead.
I think the best thing we can do right now is start a power down.
Right about then, it was quite apparent to me that it was just a question of time that the command module was going to be dead.
You don't want to get fuel cell pumps off, do you?
We can do that on fuel cell number 1 flight.
Okay, well, let's make sure we don't blow the whole mission.
When I looked up and saw both oxygen pressures, one absolutely zero and the other one going down, it dawned on me, and I'm sure Jack and Fred about the same time, that we were indeed in serious trouble. The only way to survive the situation was to transfer to the LEM.
Flight Ecom.
Go ahead, Ecom.
The pressure in O2 tank 1 is all the way down to 297. We better think about getting in the LEM or using the LEM system.
I'd say this is as serious a situation as we have ever had in manned space flight. We've always called the LEM a good lifeboat under those circumstances. If at any time in the mission, however, the LEM had separated and we had gotten ourselves into a rendezvous situation or the command module being around the moon, then what you state is absolutely true. It would be a fatal situation.
Tell me you from Flight. Go ahead, Flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
The accident had occurred 200,000 miles from Earth. Lovell, Swigert, and Hayes rode in the lunar module attached to a lifeless command module. Apollo 13 had started as a mission of scientific exploration. It was now a matter of survival. One of the big problems was consumables. There would be enough to eat and drink. But in space, there are other factors. Oxygen to breathe, electrical power to keep the spacecraft alive, water to cool the equipment and keep it operating.
What we'll be doing till we get them back on the water is concentrating on everything that is their lives are dependent upon at the moment, rather than worrying about the accident, because there's nothing we can do about that now. It appears at the present time that everything is under control and that we have a safe situation at the moment.
Hey, I want to say you guys are doing real good work.
So are you guys, Jack.
We are about 70 hours from home, and we think we have the situation in control. We've projected the consumables as I've described, and we have a plan for carrying out the rest of the mission, but there's going to be no relaxation at all as far as that goes from now until splash.
They passed 137 miles from the moon. For Lovell, it was the second time that he had seen the moon so near. But there was no time for contemplation. There was another critical burn coming.
Okay, look, let's get the cameras put away. Let's get off this burn. So, we have one chance, Al.
On April 17th, they prepared for re-entry. After a small course correction burn, they jettisoned the damaged service module.
Step.
Copy that.
And there's one whole side of that street missing.
Is that right?
The whole panel is blown out, almost from the base to the engine.
Really a mess. Man, that's unbelievable.
Next, they got back into Odyssey to jettison Aquarius prior to entry into the atmosphere.
Left jettison.
Okay, copy that. Farewell, Aquarius, and we thank you. Okay, LOS in a minute or a minute and a half. At entry attitude, we'd like Omni Charlie. And welcome home. Odyssey Houston standing by, over.
Okay, go.
Odyssey Houston, we show you on the mains. It really looks great.
Apollo 13, this is recovery, over. They're going through 5,000. Under Apollo 13, this is recovery, and your chutes look good. Apollo 13, this is recovery. We observed your RCS burn, over. The recovery, Apollo 13 is descending. Apollo 6 is recovery, over. Photo 1 spliced in at this time. The three chutes are displaced in the water. Our 0 degrees magnetic free at 1/2 miles. Iwo Jima. Iwo Jima, roger. This Photo 1, the command module is stable 1 at this time. So ride it comfortably.
I recall, Captain, that when I spoke to you on the phone, you said that you regretted that you were unable to complete your mission. I hereby declare that this was a successful mission. From the start, the exploration of space has been hazardous adventure. The voyage of Apollo 13 dramatized its risks. The men of Apollo 13, by their poise and skill, under the most intense kind of pressure, epitomize the character that accepts danger and surmounts it. Theirs is the spirit that built America. Your mission served your country. It served to remind us all of our proud heritage of a nation, to remind us that in this age of technicians and scientific marvels, that the individual still counts, that in a crisis, the character of a man or of men will make the difference.
On February 4th, Apollo 14 went into orbit around the moon.
This is really a wild place up here.
As Apollo 14 was on its first orbit, the third stage of the booster smashed into the moon at its planned target point. Its impact picked up by the seismometer left by Apollo 12. The structure of the moon's interior is one of the major mysteries of lunar science. Now another piece was added that could help solve the puzzle. Later that day, Shepard and Mitchell climbed into the lunar module Antares and undocked prior to descent.
And we're free.
Beautiful. Very good.
10 seconds to go.
Okay, there's pitch over. And there it is.
Right on the money.
Right on the money.
That's beautiful.
Right out the window, just like it would be.
There's Houston. You're a go for landing.
Cone Crater, a major objective of this mission to Fra Mauro. A hole blasted in the moon's surface eons ago that could provide a scientific clue to the history of the moon, the Earth, and the solar system.
Right on schedule.
10 years later, 114 hours, 22 minutes after leaving Earth, Alan Shepard stepped onto the moon.
It looks like you're about on the bottom step and on the surface. Not bad for an old man.
Okay, you're right. Alan's on the surface, and it's been a long way, but we're here.
4 minutes later, he was joined by Ed Mitchell.
This one is a long one.
Following the tradition of two previous missions, Shepard and Mitchell planted the flag in the lunar soil.
How's this, Bruce? Look okay?
Roger, that's a good site.
Finding a suitable site to place the scientific instruments was the next order of business. Shepard and Mitchell now began setting up the automated scientific laboratory. A small nuclear generator to power the array. The central station to transmit data to Earth. A seismometer to detect and measure activity on and within the moon. A series of 3 experiments to measure charged particles near the lunar surface. An independent experiment to reflect laser beams from Earth, enabling extremely precise measurements of such things as Earth-to-moon distance, the wobble of the Earth's axis, continental drift, and shifts of the Earth's crust. And a mortar to be fired by a signal from Earth sometime within the next year. The impact of its charges would be picked up by Apollo 14's seismometer. As a final exercise, Mitchell used the thumper, a device to explode a series of controlled shotgun-like charges. The vibrations from these detonations were picked up by a series of instruments he had previously deployed. With the instruments set up and operating, they headed back toward Antares, pausing on the way to collect samples. They loaded their 44 pounds of lunar material aboard the lunar module, and after 4 hours and 50 minutes on the surface, climbed back into Antares. As Shepard and Mitchell rested, Stuart Roosa continued his work from lunar orbit. His photographs would have meaning not only to the scientific community, but would have direct bearing on the planning for coming missions. But now Shepard and Mitchell pushed on. After a brief stop at a second survey site, they began their assault on Cone Crater, a climb not only toward the summit of a lunar mountain, but back through time.
A large crater acts in many respects like a drill, throwing out material from deep beneath the surface. This material should be very different from any we've collected before, perhaps dating back to the origins of the moon and even the solar system.
Why don't we pull up beside this big crater, pan at the map, see if we can find out exactly where we are.
The maps they were using had been made from photography from lunar orbit. The hummocks, craters, ridges, and boulders took on a new appearance when seen from the surface.
The limb looks like it's got a flat over there, the way it's leaning. Start on up to the rim? Yeah, just 1 second, though. Hey, pull a while out. You're having all the fun. And the grade's getting pretty steep. Al's got the back of the mitt down. We're carrying it up. I think it seems easier. Well, I tell you, we're really going to get a panorama. We got a tremendous one here, Houston, already. And we're not quite to the rim. But the rocks and boulders getting more numerous toward the top here. Okay, well now that's apparently the rim of Cone over there. And we're about almost 2 hours now. That's at least 30 minutes up there. It's going to take longer than we expected.
Now they were working against time, against the oxygen and water left in their backpacks, against the alien terrain. Top a ridge, thinking it's the rim of the crater, and there's another ridge ahead of you.
I don't think we'll have time to go up there. Oh, let's give it a whirl. Gee whiz, we can't stop without looking in the Cone crater. Okay. We'll press on a little further, Houston, and keep our eye on the time.
Okay, and so right now we have a 30-minute extension.
Looks like we'll be approaching the rim here very shortly. Okay, we better reconnoiter here. I don't see a crater yet.
Standing in a boulder field surrounded by rocks 10 to 12 feet long, the astronauts made their most difficult decision. With the concurrence of Mission Control, they stopped their climb less than 150 feet from the edge to begin the more important job of collecting samples.
The crew had no way of realizing they were so close. It was a week after the mission before we determined this by photographic analysis.
Again, it was time. Time to head back to the lunar module.
We're approaching the rim now. Coming in a 4-mile base.
After a quick side trip to check on the science station, they loaded the lunar module with samples and data and stepped off the lunar surface. The second expedition had lasted 4 hours and 35 minutes, a total exploration of a record 9.5 hours. 33.5 hours after they landed, Alan Shepard and Edgar Mitchell lifted off in the silent vacuum of the moon.
Gas engine is armed. 6, 5, 4, 3, 2, 1, 0. We have ignition. What a liftoff. And liftoff. Roger, ignition. Boom. There's pitch over. 10 seconds. Roger. Hey, baby. Pitch over is good. Okay, I'll do a loop later. Okay, make it smooth. And around we go. Show us a little style. Oh, you look good. There I was at 240,000 coming over the top. That's our home away from home. Would you believe 360,000? Yeah. Kitty Hawk is doing an extremely smooth loop. We're sitting at 70 feet, watching him go around. He looks very clean.
extremely important. It relates to the question of why we're fooling around with the moon. It's really that the imprint of history, of solar system history, on the Earth-Moon system is centered on the moon for the first billion years.
What do we hope to gain is we've got a window right now between t equals 0, the beginning of the solar system, and when the Earth so totally messed up itself that we can't look at it anymore. We'd like to look in there, and that window's on the moon.
Apollo 14 has already had a very big scientific impact, and we still have 3 missions left. They'll be heading into even more rugged and more interesting areas of the moon.